it will have some base, and it's going to have some input, and it is going to give us some output. Suppose if somewhere you find this thing written log having base 3, input 9, then what will be the output? Suppose if I ask you that what must be placed at the power of the base, which is 3, so that it becomes equal to 9, 2. So that is going to be the output of log having base 3, input 9. So can you answer this thing? If I write on log having base 10, having input 1000, what it will be? Yeah, 3. So what must be given to the power 2 of 10? So that becomes 1000. That will be 3, correct? So if I ask you what will be the log, any base, maybe suppose I write 3. Input 1 will be equal to any idea, any guess? So we will ask what we are going to place here at the power of 3 so that it becomes 1, 0. Yeah. So anything having power 0 will become 1. So it is going to be 0. So what should be placed at the power of the base, which is 3, so that it is going to become 1, 0. That will be the outcome of log base 3 input 1. So any log, any base, log 1 will be always 0. So this is what really log is all about. And to find the log value of such things like this, you can tell. Like log having base 10 input 1000. For such thing, you can find out. But for something not so simple, we are going to use log table that we are not going to discuss because that is of no use. So maybe in maths you will do those things. No use of such things you are going to have. Even I forgot how to see log table, man. In chemistry, maybe, but not in physics. But in chemistry, you will mug up some log values. It's not like you will use table there. Okay, like log t2 is this much, log 3 this much, log 5, log 6, like that. You will mug up some of them, or maybe if not mug up, or many times the values of the log will be given in the question. So it's not a problem. But you must understand such standard things. Like if I write maybe just one more, log having base 2 input 4 will be how much? 2, no? Log having base 3 input 9 will be how much? Input 27 will be how much? 3. So first log formula comes from such kind of thing. If log having base b input a is equal to c, compare this one with this one. So if log having base 3, maybe I'll write that old one. Log having base 3 input 9 is 2. If that is, then is it not correct to write 3 square is equal to 9? No? Correct or not? Correct, no? So what really happened, the 2 which is on this side went to the power of 3, no? Same side kind of thing we are going to do here as well. Log having base b input a is equal to c. If that is true, then b to the power c will be equal to a. Clear, no? That is first rule of the log. Next thing you should know, any log, any base, if I write a log formula without mentioning the base, it means that formula is applicable for every base. So if I write log 1, it is going to be equal to 0 always. The next log formula is, it is called like product rule. Log a plus b, or maybe I'll write other way around also, both are correct. It is equal to log ab. For example, log 2, log 3 is going to be same as log 6. So in every term of log, log A, log B, or log A into B, the base they have same sign, whatever it may be. So I'm not mentioning the base. The next thing is called quotient rule. Log A by B is equal to log A minus log B. Like for example, log having any base, suppose I give you 3 by 2. That is also equal to log 3 minus log 2. So if that is true, can you find out the value of log 1, any input, any base, log having input 1 by x? Whatever may be the base, you don't worry about that. So log 1 by x will be equal to how much? It will be equal to log 1 minus log x. And any base log 1 is what? 0. So, so that is something comes common while doing some calculations, not a rule. Special rule it is. Just it comes in use maybe sometime. So I'm telling you this thing separately. That is log 1 by x if you have it is equal to minus log x. Okay. Now suppose if I have log 4 or maybe log 8, or suppose if I have log 4, then I can write it down as log 2 into 2. So I can use that log formula. What is that? Log A into B is equal to log A plus log B. So log 2 into 2 will be equal to what? Log 2 plus log 2, no? So even I can write like that also. Log 4 is equal to log 2 square, no? So what really log 2 into 2 is, it is equal to 2 times log 2. So log 4 is log 2 square. So I can write it down as 2 times log 2 also. Good. Because log 4 is what really it is equal to 2 log 2. So there's a pattern here, no? Its power is 2. So it became 2 times log 2. Same way, any log you have having power n, input is having power n, any base. Suppose maybe if you have such confusion, I'll write something to be the base. I'll write base as base only. Any base, the input given to him is x power n. So that is equal to n into log x, but with same base. So LHS, RHS, every term has same base. So same base, so maybe I will not write that base. That is what I have done here, no? So this term log AB, whatever base it has, same is the base of log A and log B. So I'm not mentioning what is the base I have in LHS and RHS, which means same, whatever it may be. Clear, no? So did you start recording? I started recording it. Okay. You're not understanding it. No, sir. No, but still I'm recording it. But don't depend on recording. Try to understand it here itself. It's not like you have to understand, man. Remember this formula. What is that to understand? Log AB is log A plus log B. Log A by B is log A minus log B. So rarely you will use it also. It's not like so much use it has got, but just keep it in mind. If it stays in mind, good. If not, still good. Because once it is done in maths, you can't forget any of this. In maths, it will be done so much. You know, even for CBSE maths, you will not be able to forget any of this. Okay. So it's like so many things I wrote here now, and I'll write freshly on a new page. Okay. So first formula is log having base B input A. If it is equal to C, then B power C is equal to A. First formula. Next formula is log A into B is equal to log A plus log B. Next formula is log A by B is equal to log A minus log B. Next one is log x to the power n is equal to n times log x. This is not a formula, this is something you should know. Log 1 is always 0. Then If you get somewhere log 1 by x, that will be equal to minus log x. Okay. So tell me one thing, what will be log 3, 3, man? Base 3, input 3. 1, yeah, correct? So log 3, 3 is 1. The reason is 3 raised to the power what will become 3? 1. So 1. So that is going to be like a result you should know. That log base A input A will be equal to 1. Equal a base and input are equal means like 1. Okay, now sometime there can be a requirement. If there cannot be, there will not be ever you are going to have such a requirement while doing physics. Forget about that. Okay, but log I started something I should tell them. So I am telling that thing. Sometime in maths you will have such requirement will be correct statement that you might have to in chemistry you will have that requirement guaranteed, not in physics. But for basic math you should know. So we are doing basic maths not like it is going to be of use in physics only, even in chemistry also. You can turn on the camera so that you feel more class kind of thing. I don't like in front of camera, so you come more than me.
Legs camera.
Where is your hand coming around? Then after that, suppose if I have to change the base, how I remember that formula, I'll tell you. Suppose right now the base is B and I want to use a new base. Okay. So whatever new base I want to use, you write down like this. You write log in numerator denominator. The new base that you want to use, you write that CC in the base of both of them. Okay, that new base. So maybe I'll write that thing. B is the old base and C is the new base. Okay. Then in here AB written, who is like lying on the top? A. So A you write in numerator and B you write in denominator as input. For example, suppose if I have log having base 3 input 5. The new base that I want to use is suppose 7. Okay, suppose 7. So I will write log 7, log having base 7, then 5 on the top. So 5 given to the numerator guy, 3 given to the denominator guy. Okay, this thing clear? So one more formula you have now. Just try to remember if you can, good. If not, still not a problem. So when you come across such kind of use, you come back and check out this formula. Don't mug up and all of it. So log having base B input A, new base C. If I have to use it will be log having base C input A by log having base C input B. There's one more thing I have to tell. Suppose if I have log having base B input A and I want to use a new base which is A only, maybe
New base.
A, suppose, yeah, A only. Suppose new base that I want to use, suppose is A.
You haven't given any question.
No, I just am telling you something. Just check out whether you understand or not. So log having base B, right now the base is B, input is A. Suppose I want to have the new base to be A. Maybe I want to do because I can do. So suppose if I use the base new one as log A, I will write who comes in the top A, so A, no, comes in the bottom B. So tell me what is log A? A is 1. So what it is going to become? 1 by log AB. It's like base and input getting interchanged, no? So for example, if I write log having base 3 input 2 is equal to reciprocal of log having base 2 input 3. Clear, no? One more formula, so many formulas. So log BA is equal to 1 by log AB. Okay. So which formula you should never forget? First one at least, and maybe second one and third one. Three you should not forget for doing physics. Sometime we might use it. Okay, I can take a new page. For those who are at home, I can take a new page. You don't have to use mic every time. You can reply like this also.
Okay, sir.
Okay. Now, the thing that is going to be in physics every time, the base that you are going to have every time will be there's something called as Euler's number. Okay. Math sir will be discussing in detail also, maybe. Yeah, what really this Euler's number is. So it is a irrational number, somewhat like pi. As you know, pi, if I ask you how much it is, you will write 3.14 and it'll keep on going. Never ends. Same kind of thing E is, but nearly its value is equal to 2.4. That too you don't have to know. You have to know his value more than one. If you can remember that, it is enough for drawing facts. So whenever the base of the log or logarithm is E, it is called as natural log. So if I have base which is E, that is called as natural log. So in physics, if I write somewhere log having no base, by default you will mean base is E because we do natural things. In maths, maybe it might be 10 because there is a particular use of 10 there and have to do with something math thing that I don't want to discuss because we don't have that kind of time. Okay, so our other shortcut way to write this thing is lnx. Maybe we are studying in ln, so you write lnx. Okay. So just you know this thing, that is enough. For this test, after that you forget it also, no problem. For doing this is not requirement. Because right now if I have base A input x and I want to use a new base which is E. E, the Euler's number, some people pronounce it as Euler's number, but I do Indian pronunciation, not real pronunciation. We will have our own pronunciation, no? Correct. So suppose the new base I want to use is EE, so I will write log having base E in numerator denominator both. Then you write, so x is in the top, you write in the top like that. Okay, maybe this way also I can do since log having base E input A is equal to reciprocal of log having input A base, correct? I can do this reciprocal thing. I can interchange the base and input, but it will be reciprocal of that, correct? What I'm telling is if that is written like this, it's not something should be confusing you. Log EA is reciprocal of log A, correct? So it can be also written like this log AE. We don't want to write anything in denominator, feels weird. You write like that also. That is not wrong, no? Clear, no? So logarithm over. That's all. And this part, suppose right now the base is A. I want to use a new base. What new base? E. So numerator, denominator, both the guys has EE. Then who is on the top? X,
X.
X. Bottom A, A. This my part clear?
Yes, sir.
Now next part is if I have log, you see what really I have in LHS. Base B input A. It is reciprocal of base A input B. Like log 3 2 is 1 by log 2 3. So log EA is 1 by log A. Correct. So log EA, replace it with 1 by log AE, where it will go in numerator. No?
Okay.
But,
Yes, sir.
so if this one written, we should not be getting confused. Okay. Just try to remember till this Wednesday, then you forget or no problem at all. Because that is not really we ever do in physics. So our physics will be mostly revolving around sin x, cos x, e power x, life over man. Maybe some simple polynomial function. That's all. Now we will go back to our differentiation, the main thing. Okay. Okay. So dy by dx is an operator we talked about. Anyone having any confusion regarding whatever that we discussed in differentiation? Anyone? You can tell me, man. Anyone? If it is confusing, it will be, man. It is confusing, obviously. And who invented calculus? Do you know? I told that thing. I told that thing. No?
No, sir.
Okay. So if you go in actual chronological order, we have proof, actual text. We have that we Indians got the idea of calculus long before Newton. Anyone got that idea? Like 300, 400 years. We have before proof. We have written proof. There was a time when people never used to write; they used to just pass it on by oral tradition also. So we don't know how long back we. So Kerala Book of Mathematics has records of that. Not like beginning calculus, like basic calculus, full-fledged modern calculus, that much. But Newton also invented that, and in the lifetime of Newton, one guy sitting in Germany also invented that. Not like they were talking with each other or they have shared any ideas. Two people at different point of time can come up with same idea, no? Same idea which is universal, correct? It's not like uh, truth is good thing and telling lie is bad thing. Indians only got to know that thing. Like anyone can tell this thing. No? So why Newton invented calculus? After the death of Kepler, he got the data the Kepler collected. From looking at the data, he got the intuition that okay, force of gravity must work like that. So to prove his laws of gravity, he invented new kind of mass, that is calculus. So it's like we are trying to think how come, what is this new branch of mathematics is all about from scratch. We are building up that from scratch. So and for 11, 12 class students only. So obviously it will be confusing. Confusing or not confusing, all of you have understood.
Yes.
Okay. And what I was going to talk about that table, no? So now whatever it is, it's not conceptual or like anything where to imagine or anything. Now things are going to be algorithmic. So whatever confusing part was done now that you have handled. Now the part that comes is like algorithm you have to follow through. Don't apply brain, do this, do that. That's all. So in one column we are going to write the function, next column the differentiation of that function or derivative of that function or rate of change of that function. Constant one we got it 0 it was no. Yeah, just for continuity I'm writing. For x power n into x power n minus 1. Sin x, his brother cos x, so cos x. Cos x brother sin x, but he's like bad brother, he brings minus 1. Tan x, secant square x, secant x, secant into tan x, cot x minus cosecant square x, cosecant x minus of cosecant x into cot x, e power x, nice guy, is differentiation e power x. Log having base e, these are the ways to write it down, its differentiation 1 by x. So that is one set of rules. Another is something, now whatever rules I'm going to tell now, is it will feel so obvious that you will think, sir, why you're telling us this rule, this we could have thought on our own also. Suppose if I give you y equals sin x, you know how to find its differentiation. So dy by dx of sin x will be, how you're knowing it from marking up this table, cos x. So next if I give you, okay, y is 3 times sin x. So what will be the differentiation then? So I will do like this and tell me it feels logical thing to do or not. 3 I will take outside and I write down that will be equal to 3 times dy by dx of sin x. So logical or not logical, this is what we do. Suppose if I give you y equals x, what is the slope is? 1. Y equals 3x, what is the slope is? 3. 3 times 1, no? Got the logic, no? So what is the rule is, if so it's going to be simple. Differentiation of 3 times sin x is equal to 3 times differentiation of sin x, as if we have taken 3 outside the operator, as if you take something common outside, some bracket kind of thing. Yeah. Yes. So that will be 3 into cos x or 3 cos x. So the rule goes like this. If you have some constant multiplied with some function of x, and you have to find its differentiation, that is equal to constant into differentiation of f of x, that way. Another rule also will feel like very obvious kind of rule. And what is that? Suppose if I tell you, find the differentiation of y equals x square plus or minus sin x. So basically I'm asking you to find the dy by dx of x square minus sin x. So see, what I will do next is, it's so natural thing to do, you will end up doing this even someone telling you to do like that. It will be equal to differentiation of x square minus the differentiation of sin x. And we know how to find differentiation of this all 2x, and that is cos x 2x minus cos x. So what really I'm trying to tell is, if you come across such kind of thing like dy by dx of plus minus some function of x plus minus a function of g and so on, that is equal to plus minus. So you don't touch the operator that are present before every term. Like sin x contains minus 1 in front of it, minus. So minus between these terms as well. You can see that, you know. So it will be plus minus dy by dx of f of x plus minus dy by dx of g of x. So this is something basic. This much you should not forget. Somehow you have to remember them. Next table, I'm going to write down. And whatever the results that are going to be in the next table, we can derive it after some time, but not now. By proper method also, by recognizing pattern also. Copy this thing, everyone. Anyone having any confusion? Anyone? If confusion there, it is totally natural to have. You should ask them. And if someone thinking more, they might get confused more. So if you're getting confused more, it is not wrong thing. It could be like more good thing. Because your brain will not be suddenly accepting such a new idea straight away. It will question it first. It's straight line things, all of you got that, no?
Yes, yes.
So whatever I will do till today, up to that only things will be coming in the exam. And again, we have class on Monday and Tuesday also.
We don't need to read.
Uh,
No.
that much, you don't have to become pro in maths, man. You understood the class, things done, ready to go. Yeah. Just for the sake of the test, you do some practice. Why practice? So that you will not be marking up this formula like atomic number of carbon is this without to straight away remember such thing. So you will be remembering the formulas of the maths by doing maths. For that purpose, solve the module, not even required to do physics. Okay. Maybe not for test also. If your memory very good, then no problem. Or if you don't commit mistakes. So every time solving module is not just for checking your knowledge or anything. It's also for having enough practice. And some questions in module are like such thing you will never be doing in physics. And those things are so easy that so much easy you will not be doing in maths also. Got the point, no? So it is irrelevant in physics because it is difficult. Irrelevant in maths because from point of view of maths is so easy. Even in CBSC board exam of Pakistan, they will not ask. Like even poor country or not poor. Okay, leave it. I can take any question. Yeah, I was seeing one YouTube video. Some guy in some place like Pakistan was claiming that Earth is really flat, but the photos of the round Earth you see that is photoshopped photo. It is conspiracy of NASA. Like, can you imagine? They were telling like round Earth and all is like conspiracy photos, photoshopped photos from NASA. Earth is not really like that. And what kind of hole they live in? No? That's why I don't want to record it, man. If I'll suppose hear it goes into, I can, because in class we can say things that we can't say online because we understand each other, but we must say everything, man. If actually we can't see freely, tell things freely, what kind of country we live in. Okay. So next table. So, but before I tell you the next table, try to check out this thing. Suppose if I write sin x, one thing, and next I write sin 3x plus 5. Can you see the similarities and the differences? So in here, the input variable x, but the thing that is given to the sin x to eat is x. Correct? Now input variable x, suppose I gave some guy 10 rupees, he is making 3x plus 5 of that. Means he is making how much? 3 into 10 plus 5, 35. So on giving x 10, sin not getting 10, he is getting something else to eat, no? But what matters is what sin x really gets, right? So in this first case, I will say argument of the function is x. The output of the function is decided on the basis of just x. Clear? But in case sin 3x plus 5, I will say the argument of the function is 3x plus 5. I'm not telling that I read that definition in book or somewhere. I read argument thing, then I thought this might be the meaning. I hope you agree to same meaning, no? Argument of this function is 3x plus 5. Why? Because what really affects the outcome of sine function? 3x plus 5. No? When I have x10, what is the angle given to sine really is 35 degrees. Correct? Clear, no? Okay, then. Why I'm telling you, maybe reading some text on your own, you come across argument of a function, you should know what really it means, no? How it is different from input variable. So 3x plus 5 depends upon x here. It's obviously depending upon x. But the outcome of the function, who immediately affects the outcome? 3x plus 5. Clear? No? So next table, I'm just giving you, but I should not give this table because very soon you will be able to derive the things that are in this table on your own even. So we'll be doing some proper way by which we can derive the things that I'm going to give in this table. Even in spite of that, you can find the answers of this table by knowing this table. Okay. Suppose, so try to recognize some pattern. Okay. If I give x having power n, what is the differentiation it has? Correct? So I'm asking you to guess. So guess means you can be wrong, so it is totally fine. So x to the power n has differentiation that. So if I give you ax plus b, uh, for example, 3x plus 5 having power n, what really the differentiation you might guess. So whatever is the thing inside the bracket here is x. So you see what has been done to him. He is multiplied with his power and his power reduced by 1. So whosoever comes in this place, so here x got beaten up and someone else came in place of x, they all will be beaten up. Got the point, no? Ax plus b is coming in the place of x. So what we will do? We are going to multiply him with n, his power, and we are going to reduce the power of the bracket by 1. No? Whosoever inside the bracket, we are reducing the power of the bracket by 1. But that is not the formula, actually. Some slight different it is that I will write down here. Ax plus b having power n, its differentiation is, so what is the coefficient of the variable term x here is? A. So you multiply by a and do the same old thing. And into ax plus b to the power n minus 1. This is what I was telling. So this pattern, you got that? No? So whatever was done to x or whatever thing is done to whosoever is inside the bracket, same thing is done to whosoever is inside the bracket. Or whatever is done to the bracket, same thing is done to the bracket. So he is multiplied, bracket is multiplied by n, and the power of the bracket is reduced by 1. So same thing I have done here also. Multiplied by n, power of the bracket reduced by 1. Extra thing you have to remember is you multiply it with the coefficient of the variable term here, that is x. Clear? No? So can you tell me what can be the differentiation of sine ax plus b then? So see the old formula, sine x becomes cos x. So it will become cos ax plus b. But extra thing we do is multiply by a. After that we have cos ax plus b. Cos x becomes minus sine x. So this will become minus sine ax plus b multiplied by a. Yeah, correct, like that, yeah. What the pattern? But even without that, we will know by proper method that will be discussed later on. Okay. Once I complete few more things. Tan ax plus b, tan x differentiation was secant square x. Tan x differentiation secant square x. So tan ax plus b will become secant square ax plus b multiplied by a. Then I will write e power ax plus b. Can you answer what it will be? E power x, nice guy, nothing it happens to him. As if differentiation is not affecting him. No, it's like immune to differentiation. So e power x plus b will become e power x plus b. Extra thing is multiply by a. Correct. Log x differentiation was 1 by x. So log ax plus b differentiation will be 1 by ax plus b. Correct. But extra thing is we multiply by a. So whatever missing, you write those terms on your own, man. You missing, no? So missing ones are not important ones. This you should not forget. So missing ones you write down on your own, everyone. If you cannot, you ask me. I will write it down then. Copy this table and write the missing ones. Which ones? Secant ax plus b. Maybe I'll write those ones. Secant ax plus b, you write what it will be. Then cot ax plus b and cosecant ax plus b. Okay. Maybe volume more, but not difficult thing, no? But this all things you will remember by practice only. Don't worry about this. Give it like 1 week. After that, it's going to be like so easy. But 1 week it will take. With this exam, you have a choice. If you want to write the exam, you write. If you don't want to write the exam, you don't write. You have a choice. Because this exam should not be held so early, man. Generally, exam will be held after 15 days. So it came so soon. So if you will not write this exam, we will take a test afterwards for the same thing. You have a choice. But if you want to write, you can write. Syllabus will be done. Okay. I told them that okay, why you're taking exams so early. So they told okay, it's decided. So tell them they have a choice. They can write. Some other time also, maybe you can skip this one if you want. But skipping the physics one is not a problem because it's not physics. If you're understanding some of the things also in the class, no, some of the things, still enough. For this test only, I'm telling. Same thing will not be there in other tests once the real physics will start. So this test you get zero also, no problem, man. If you are understanding some of the things also in the class, enough. But for chemistry and maths, it might be important, correct? So that's why maybe you attend. So secant ax plus b will be, so secant x was secant x into tan x. So this will be secant ax plus b into tan ax plus b. Extra thing is we multiply him with a. Cot x was minus of cosecant square x. So cot ax plus b will be minus of cosecant square ax plus b minus of cosecant square ax plus b multiplied by a. Cosecant x was minus of cosecant x into cot x. So this will be also minus of cosecant ax plus b into cot ax plus b multiplied by a. So by this two table, 99% time done physics questions. But for 1% time, whatever will be done from now on is for that 1%. And by the time, and in 11th class, by this much only done. Maybe in 12th class, maybe you might be using the next 1% time, whatever will be discussed from now on. But by that time, these things will be over in maths also. So it's not going to be a problem. Even if it is over in CBSE maths also, first day of CBSE maths over, done. First two, three examples of is NCRT of CBSE maths you can do, done. Even that much not required. Okay. I can take a new page.
Yes, sir.
So next thing is something called as product rule. Its name is suggesting when you will use when you have product of two things. No, that's why his name is product rule. Why else his name will be product rule? So suppose if I give you, suppose y is equal to x square into sin x man. If only x square given, we know the formula, no, 2x. If only sin x given, we know the formula cos x, correct? But product of these two becomes something else. We don't know anything for that. Maybe I'll write like this. You can recognize which two separate things we do or which two separate formulas we know of x square. I'll think as if I have one function f of x which is x square and we have another function g of x which is sin x. So the product of f of x into g of x, we have to find out the differentiation of that. Correct? So how the formulas, so some formulas are so naturally, so easy, so obvious looking formula you can't forget. It is of some, it is of such category. So what you will do, f of x and g of x both are like inside the operator. So you send f of x outside to play and g of x will remain inside for studies. And g of x will cry when I also want to go outside, so send him out and f of x will remain inside. So have you got the formula now how it works?
I can see it.
You can see it now. Now you can see it now. So we have f of x, g of x product inside the operator. So at a time you take one guy inside. Send f of x to play outside, g of x remains inside. Means you multiply f of x with differentiation of g of x and then reverse g of x into differentiation of f of x. Clear? now? So we'll write in this way. So for example, if I give you find the differentiation of x square into sin x. So what you will do? Anyone you can keep as it is first. You keep x square as it is, or you keep x square intact. You multiply him with differentiation of the other guy sin x. Then reverse. You keep sin x as it is, and you multiply it with differentiation of x square. Okay. So differentiation of sin x we know, no? Cos x to x square into cos x, and differentiation of x square we know that is 2x. So what we get? X square cos x plus 2x into sin x. So can you do one thing just for practice? Find the differentiation of e power x into cos x. Do it now, everyone. Find the differentiation of e power x into cos x. So at the time you will keep one guy as it is. Suppose I keep e power x as it is. So e power x into cos x. Then we'll keep cos x as it is and we multiply him with differentiation of e power x. So cos x differentiation is minus sin x. No? So e power x into minus sin x. And e power x differentiation is what? E power x, so e power x. So what it becomes? Minus e power x sin x plus e power x cos x. So you take out common e power x. You write cos x first. So cos x minus sin x. Okay. This is how product rule works. Okay, I can take a new page. See? Do one thing, find the differentiation of t ln t with respect to t. I hope it is not confusing thing to anyone. I could have given find dy by dx of x ln x. No, instead of x t comes. No, that's all. No, like for example, differentiation of x power n with respect to x is n into x power n minus 1. So differentiation of t power n with respect to t will be what? I don't have to tell new formulas for new letters. No? You can see the thing on your own. Instead of x, I have t everywhere. So t will be replaced with x will be replaced with t everywhere. No? Because for every letter, if I'll tell new formula, then there are so many letters involved. No? So can you find the differentiation of this thing? Find dy by dt of t ln t. So what you will do? One function in here is g, which is a function of t, and that is t. Another function that you can see here, suppose function name is f, a function of t, which is ln t. Is product of two things. So you will keep one of them as it is, and you will be multiplying him with differentiation of the other one. So t into dy by dt of ln t or log t, then reverse. Ln t will be kept as it is into differentiation of t with respect to t. So what is the differentiation of x with respect to x? We found that thing in the starting, no? 1, no? And we know we can use this formula. I have to find differentiation of what? X power 1. So 1 into x power, look here, x power n formula. 1 into x power 1 minus 1. So that will be 1 into x power 0. That will be what? 1. Clear, no? So differentiation of ln t is how much? 1 by t, no? Differentiation of log x or ln x with respect to x is how much? 1 by x, correct? Formula. So differentiation of ln t with respect to t will be how much? 1 by t, correct? And then ln t into differentiation of t with respect to t, and what it is? 1, no? And it looks like that also, no? And dt I can cancel also. Is it not like that? Kind of, no? 1. So what it is going to become after that is t into 1 by t will become 1. 1 into ln t will become ln t. Or what really ln t is. Can leave it there, but maybe you can write like this also. Log having base. Clear this thing? Clear, no? Clear, no?
Significant difference.
Okay. Remind me, I forget. I start writing like that, no? You can see from here. Okay, I'll make it big also. How to make it full screen, man? Okay. We can take a new page. Do one question in the module. Page number 60, question number 12. Same like this. Page 60, question 12. Please try everyone. Page 61, question number 15. These two questions, all of it, try fast. Page 16, page 60, question number 12. You try first, then page 61, question number 15, you try next. Okay. And then question number 19 also. So it is given that P is something, you don't have to know what it is. Think like some math question you're solving, don't care about what P is. Given some quantity P is equal to T ln T. And it is told, okay, some other quantity F, which is dP by dt. So P is a quantity which is a function of T given. And F is a quantity which is differentiation of P. So when that quantity F is 0, when differentiation of P is 0, correct? So to find when differentiation of P is 0, what you will do first? You will find the differentiation of P. So differentiation of P is what? T ln T. Same thing it is, no? Just now we found no dP by dt, T ln T, no? What is that? I gave you T ln T to differentiate. No, same question, but extra thing they're asking us. Fine, they're asking us at what value of the T that dP by dt is 0. So you will use one log formula. So we'll take a new page, there I will write. They are telling us P is a quantity which is T ln T. Okay. And they're telling us F is equal to dP by dt. So dP by dt will be dy by dt of this T ln T that we have found just now, no? And that came out to be 1 plus ln T. And they're asking us for what value of T F is equal to 0. So I will equate F to 0 to find for what value of T it becomes 0. So what I get is 1 plus ln T equals 0. Correct? Ln T means what P, what log? Log having base E, no? So 1 plus log having base E is equal to 0. So log ET is equal to minus 1. Now we will use that log formula. Suppose you forgot that one. But don't forget this example. Log 39 is equal to 2. So 2 on the right hand side will take the power, will go to the power of the base, which is 3, and 9 will go to the right hand side. You see what really happened here? No? So same thing will happen here also. Log, his base is E, input is T. And what is lying on the other side, man? Minus 1, no? So minus 1, the right hand side will go to the power of E. So E power minus 1. And T will go to the other side. So what T became? 1 by E. E power minus 1 is same as 1 by E. Like 2 power minus 1, what it is? 1 by 2 power plus 1. No? I hope all of you got this thing. Next, try question number 15. The moment you will see 15, you will think, man, 3 terms are there. If 2 terms there, we know the product rule. But still, don't you think you can still apply product rule? So try 15th one. If you're unable to solve, I will solve it. Never ever you will do any kind of differentiation like that while doing physics. Just to make you remember this formula, we are doing it. And that is so easy that will not be coming in CBSE maths exam also. It's like so easy and so difficult, so difficult that will not come because they will not be investing your physics time in maths, doing maths. No? So physics questions will have difficult physics, not difficult maths. It is designed like that. Still, I'm audible, no? Okay, I can take a new page. I can take a new page now. All of you got this thing? All of you got this thing, no? All of you understood, no? Those who are online should reply, man. Okay, good. So here I have to find differentiation of x square into e power x into sin x, correct? So maybe I'll consider one function is f of x, that is x square. Another function is g of x, which is e power x into sin x. So now when I go for applying product rule, what we do, dy by dx of f of x into g of x is equal to f of x into dy by dx of g of x. And then reverse g of x into dy by dx of f of x. So we get x square into dy by dx of e power x into sin x. And then e power x sin x into dy by dx of x square. Now to find the differentiation of e power x into sin x, we will apply product rule separately. So dy by dx of e power x into sin x, what we will do, same thing that we did like here, no, e power x into cos x, correct, no? So it will be e power x into dy by dx of sin x. Then sin x into dy by dx of e power x. So dy by dx of sin x is cos x, so e power x into cos x. Dy by dx of e power x is e power x, so that will become e power x into sin x. I can write it down as e power x into cos x plus sin x. So here, differentiation of e power x into sin x, we will replace, we'll substitute here, it's e power x into cos x plus sin x. And differentiation of x square is what? 2x. So e power x sin x, this entire thing into 2x. So from every term, you see, we can take out common x into e power x. So what it becomes is x sin x plus x cos x plus 2 sin x. So I can write down as 2 sin x plus x sin x plus cos x. Option C looks like, option A looks correct, no? X cos x. I hope clear, no, this thing? So 2 times we applied product rule, sort of, no? Clear, no? Uh, Never be there, don't worry. 3 terms also will not be there.
So
Rarely.
it's d power x square differentiation.
2x.
2x.
X power n formula. Differentiation of x square we know, no? We derived it in the class also, 2x. So copy this thing. Those who have copied, please solve question number 19. And question number 23. Yeah, I hope, no, after this, check out question number 23. You can solve that 23. It is differentiation of e power x into sin x. This one. 23 question is e power x into sin x. So that we can find out. Out. Thanks. Hmm? 220 it will be over. Then 2:13 next class will start. For it, it will be over fully. So how many doubts you have? Like so many. So many then you KCL KVL so 4 man. Tomorrow yeah, tomorrow also. Tomorrow also. Yeah, totally. Yeah, our class will happen here only, no? Then no, tomorrow night, tomorrow night. Yeah, after 4 also. Okay. So question number 23 also likewise done, no? 23 is e power x sin x differentiation. E power x into sin x differentiation. Now, question number 19, please try. So they have given us t equals root x plus 4. And they're asking us to find dy by dx, dx by dt. So what you will do, man? Let's solve this one. This one we have not done. Let's solve it. Let's solve it. T equals root x plus 4. And they are not asking us dt by dx, man. No. dt by dx totally we can find. They are asking us dx by dt. So you must know x in terms of t. So root x I can write down as t minus 4. So x will be equal to t minus 4 square. And I have to find dx by dt. What to do? Tell me. No, that is not correct. So check that it is working or not. This way feels more logical, like more guaranteed correct. So just now we have seen what is the differentiation of ax plus b to the power n is. It is a into n into ax plus b to the power n minus 1, correct? Where a and b are some constants. So now if I ask you what will be dy by dt of at plus b to the power n, instead of x what I have t, correct? T9, correct? So it's going to be a into n into at plus b to the power n minus 1. So is it not falling into that category? It is dy by dt of t minus 4 square. So what is n in there? 2. What is a in there? So coefficient of the variable term t has what coefficient? 1, no? If I write x, what is the coefficient of x is then 1. So same way I write t, coefficient of t is 1. So coefficient of t was a, I multiplied with a. So coefficient of t here is 1. So we multiply it with what? 1. 1 into n, which is 2, into t minus 4 having power 2 minus 1. That is going to be 2 into t minus 4. So dx by dt came out to be equal to how much? Twice of t minus 4. So they are asking us the value of dx by dt when t is equal to 4. So it will be 2 into 4 minus 4, that will be equal to 0. Right now? But so I hope you could recognize that this thing came from like ax plus b table. No? Now we are going to discuss something which is called as quotient rule.
After this correct, sir.
Correct. But we don't write like that, we write front. There was sin x into x square I can write. But x square into sin x looks nice.
2x in x square same.
Not same, just I'm telling an example. Correct, leave it here. But I took common, no? Take common, no? Take, take common, so it will be 2 sin x, x and e power x I took common. Clear, no? Then here I have x square, correct? So that will be x sin x plus x cos x. Clear, no? There is not physics, but simplification only. I hope you all of you got this one also. Okay, next thing is quotient rule. So name only telling you maybe what can be the rule for quotient. Suppose if I give you y equals x square by sin x, man. Then the thing is, I know how to find the differentiation of x square if that is only the thing given. I know how to find the differentiation of sin x if that is the only thing given. But I have to find differentiation of reciprocal of this, the quotient of these two. How the formula goes like, remember this formula. So dy by dx of f of x by g of x is equal to, how you remember this formula, I'm going to tell you. So in denominator what we have is g, no? So you square up the denominator, you write down g square x. Then something done to the denominator, no? So
So why do we square?
that is how formula goes like. I'm just telling it like a story so that you can remember it. You have to remember it basically. Then some operation done to G, he might be tired. We will tell him you take a rest. Then you keep G of x as it is. And we multiply him with the differentiation of the numerator, which is f of x. Something like product rule, no? We do differentiation of one thing, we keep the other thing intact. So first I will keep denominator intact. We multiply it with differentiation of numerator and then reverse. We'll keep numerator as it is and we will be multiplying it with differentiation of denominator. But minus between them will be present. So for example, dy by dx of x square by sin x if I have to do. So sin x denominator guy squared up placed in the denominator. Then denominator kept as it is multiplied with differentiation of numerator. Okay. And then reverse, but minus between these terms. X square kept as it is, and that is multiplied with differentiation of sin x. So differentiation of x square, how much? 2x. So we will get sin x into 2x. And then x square, differentiation of sin x is cos x, so x square into cos x by sin square x, this will be the answer. So 2x into sin x minus x square into cos x by sin square x. So After this, please do the question number 22, page number 61. Page 61, question number 22. Okay, before you do this thing, suppose y is a function of x. Then if I write dy by dx, you understand what it means.
Yes.
Another symbol of dy by dx, sometimes we use y dash. Another symbol. Like you are lazy to write dy by dx, you write y dash. Different symbol for something. Shortcut symbol. Okay.
Dash means different.
And different one time. Differentiation is differentiation. Or I can even write f dash x. For example, if I write down f of x is equal to cos x, then f dash x or y dash is equal to minus sin x. Got the meaning? I hope all of you got this thing. So that dy by dx, another symbol is y dash or, or f dash x. Dash means differentiation. Okay. Okay. So whatever we have done till now, that much only will be coming in the upcoming test. I'll give some homework. So beginner box 1, you will solve all the questions. Page number 55, homework I am telling you. Page 55, beginner PB means beginner's box 1. Exercise you can't solve much, just few you can solve. Exercise 1 on page 60 and 61. Question number 15 we have done already. Question number 17 you will try. Question number 18, 19, 22, 23. Page number 52, you will be trying the illustration 2.
Sir,
Yes, tell me.
everything should be done in the morning.
You will be maintaining 2 notebooks. One running notes, one where you will solve the module and any problem of physics from any book. Not like NCRT and those things, like something of JE, you will be solving in that. Okay. And few more questions you will try. I'll write down here only. Find dy by dx of or find dy by dt where y is equal to a into 1 minus e to the power minus bt. One question. Next question you will try. S equals a cos omega t plus phi. See, that is W looking thing, no? Like stylish W it is. It's not W, it is omega Greek symbol. It's written like this actually. And my handwriting not so good. But whatever it is, in here, a omega and phi are some constants. Some constants. Find ds by dt. Is given x equals a sine omega t plus phi. Find dx by dt when t is equal to 2 pi by omega, where omega phi and a are some constants. Okay, so this much you will try. This is the homework, and you try to give a reading to that calculus for dummies, please. Not not going to change much in getting physics things done. But if you'll give it a reading, somehow it will make you somewhat better than other people, brain wise. That can be used.
So this is differentiation calculus.
Different, that calculus different, and the calculus differentiation is one topic.
Oh.
So whatever page numbers I told no in class, I told no some page numbers to read. So please try to read. Even if you understand zero, no problem. You have to read. Maybe those things might not be of use in physics, but maybe if you read, you will be ahead of the more of the population which are competing with you. Good, no? Right? Logically, it will make you a little bit better. Okay? So there will be some subtle changes in your brain reading that thing. That subtle changes will give some unsubtle or like drastic improvement in result in future. Okay. Right now, it will not affect anything as such. Okay, then. So today's date is 17th. We will end the class now. Bye, everyone. Thank you for coming in extra class. Whatever we have done till today, that much only will come in the test. If you did not understood something online, all of it we can repeat in offline also. Okay. So then bye. We'll end the class.
Sir, I added you in the groups.
Yeah, thank you, man. That's why I was able to post the link also in the group.